Hi guys, I'm Girish. I'm a solutions architect at PubNub, and over the past 3 years, we've been working with a lot of developers to get them. Basically, my job is to share best practices, help them get the most out of the PubNub network, and we've basically seen all the problems they've solved and all the challenges they've faced, and we've just released a new product recently, and today I'm here to talk about why PubNub moved serverless computing into the network. Just out of curiosity, before I start, though, how many of you have heard of PubNub? Nice, awesome, okay. So for those who haven't, I'm just going to touch a bit on what real-time means to us and the kind of apps that we see. So in the social entertainment space, you're very familiar with chat applications, games, and things like that. So companies like, or apps like Periscope, Live360, and in the gaming world, Pocket Gems, they basically allow users to interact with each other in real time. For chat applications, it's pretty obvious that it needs to be real time in the sense that I'm sending a one-to-one message or a group message. It needs to reach the other party. In the IoT smart home, slightly different use case. You have devices that are connected 24/7. I think we've been spoiled. We expect to just take our phone, launch an app, and turn a light switch on, open the garage door. And this should happen if I'm standing right next to it or if I'm half the world away. In the connected vehicle space, we're all familiar with this, taxi dispatch, Get Taxi, Lyft, Easy Taxi. The whole idea is that I launch the app, and based on where I am, I'm seeing all the location data that's coming out from every driver's iPhone. So that's a lot of data. You have 20,000 drivers. They are constantly publishing data, and you need to be able to subscribe to only the relevant data based on where you are. Financial services, that's another industry where you just have constantly changing data. Every couple of seconds or milliseconds, data is changing, and that's being fed into a system, and now it needs to appear on your browser in the form of a real-time dashboard. You're streaming stock codes and things like that. That's another example we see. Online collaboration. We're all familiar with Google Docs, and Autodesk has similar collaboration where you're just viewing a 3D model, and then you can turn it on your screen, and it shows up on the screens of your coworkers. And finally, you have like big brand names doing audience participation with real time. So you could be at a concert, and based on the music that's being played up there, everyone's holding up their phones, and the color is changing, and all that's happening in real time. A signal goes out, in a stadium full of 20,000 people, their phones just change color. So this is how we used to do things. The Restbased architecture, we are very familiar with this. Back in the day, all your clients, your mobile devices, your browsers would make a request to a server, and then they'll get a response. It was great for the kind of data that we wanted to consume back then. Everything is constantly on now, and data is just changing so fast that you need to be able to push data the second it changes. You can no longer rely on the client to make a request and then respond with data that's stale, and stale now could be 10 seconds old data. So where we come in, or any data stream network provider really, is the fact that we basically allow these devices to connect to us, and when they're connected, they start publishing on channels, and devices are subscribed on to channels. And you can subscribe to multiple channels. You can get data as, when someone's streaming stock codes, for example, you can just choose to subscribe to 2 of the stock updates and things like that. But in reality, that's not really how it works. Every device is connected to the real-time network, which is great. But if you notice, every message that goes out needs to be processed. It's very unlikely that a message published by someone will hit the subscriber without needing to go through some kind of transformation. So the way we've seen people handle that over the past 5 years is that they always have to introduce their server. So you'll have all these publishers coming out with data that's constantly changing, and then you need a server that's taking in all this data, it's manipulating this data, it's filtering, transforming, aggregating that data, and then it's pushing it back out to the network for us to send it to the subscribers, 1 or 10,000 of them. And the problem is that it just makes scaling really hard. I'm just going to jump into an example, hypothetical example. Let's say we all work for a company, Yummy Soda, and it's a soda bowl. We want to build an online chat platform. So the whole idea is we just want everyone to come online, start chatting about the game or anything of that sort, but we don't want them to mention our competitor's name, Gunk Soda. Right? That's real-time communication for you. I send a message, everyone gets it in the stadium or everyone who's at home viewing it, but I just don't want anyone to mention the word gunk. The way it would work right now, or before we had blocks, would be as the devices grow, you get more and more people watching the game, you now need to scale up your servers because you're doing the same thing. Everyone's sending a message, you need to make sure you get the message, filter out the word gunk, and then send it out back to the data stream network. This doesn't just apply for chat applications. It applies for taxi dispatch companies too. Same thing. Drivers are basically publishing their location, and you need to aggregate that and only send it to people based on their location. Business logic in the IoT world, you have thresholds for certain devices that are sending sense temperature data maybe, and then at 70 degrees you want something to happen, and that could change to 75 tomorrow. So the whole idea is that I have to bring all this data in, and based on some rules engine, I need to maybe send out an alert. Sentiment analysis, the same thing. You have everyone publishing, they're watching, American Idol, and then they, basically are saying how they feel about stuff. Now you have to get all these votes in, aggregate them, and then send it out through another channel so that all you see is the aggregated votes. Game logic, same thing. Everyone's simple game logic that if you're playing a game of Hangman, for example, you'll need to have your server there just to make sure that turn-based and all that logic is being handled on your server. So what we've decided to do is basically bring the servers into the network. So basically, what we're doing is introducing the concept of serverless computing and allowing you to inject your own business logic into the data stream network. So PubNub Blocks is a product we have been working on for about 3 years now. We just launched it 2-3 months ago. And the whole idea is that, so we, as a global network, we have data centers in multiple continents. And anyone connects, people who connect to PubNub just connect to the closest data center. With Blocks, we're going to allow you to deploy JavaScript directly into the network. We're going to ensure that when a message is sent and it hits our network, that your function or your block gets executed in less than 10 milliseconds. We needed to be able to allow our users to scale automatically and deploy it as well. Just like your application will have newer versions and you'll push out new code for your applications, your business logic will change. So we need to ensure when you deploy new business logic that there are no downtime. We need to replicate that because we are globally distributed. Someone could connect to our data center in Tokyo, someone else could connect to our data center in California. The code that you push out has to be available in Tokyo and in California too. As a data stream network, we provide 5 nines SLA, and we needed to ensure that with the Blocks infrastructure, we do the same. And also, a lot of people publish data that's sensitive. So, when you publish an encrypted data, we do allow you to act on that data in Blocks by using the whole concept of an envelope and the content. So you can have metadata outside that you can act on, but the message itself is encrypted. So if you look back at the same problem with serverless computing, you don't have to worry about scaling servers. All you're going to do is really just write a single line of JavaScript. And that's it. It's just some regular expression magic. Every message that comes in, you're going to inspect the JSON. If you see the word gunk, you're going to replace it with yummy. And now we need a way for people to deploy this. And when we say deploy this, it has to go to all of our edge nodes, not just one data center or the closest data center that you connect to. Along with the ability to deploy, as I mentioned earlier, the whole thing about no downtime updates. So when the version of your app changes, your business logic changes, you need to be able to just push out a new version of your block. And when that happens, what we do is we basically stage it, wait for it to load up, and every message is still going through your old block. And then when the deployment is done, we just remove the old block, and now all your code is updated. One really important thing, though, with real-time messages are just coming in. You don't have state between messages, right? So how do you do aggregation of any sort? So if you think about it, it's like a voting application. It's not enough to just process the message and just forget about it. If a message comes in, you need to keep maybe a counter or a key value store of some sort. And we allow you to do it by basically having a replicated key value store, once again, right next to your blocks instance. So you could, and we have atomic operations like increment counter, right? So you could have people all around the world that are just voting, and there's eventual consistency. Because as the votes are coming in, you're updating the key value store that's closest to you. You could be publishing the results on a separate channel. Just going to skip through this. So the whole idea is that a lot of what we've built has been possible because of all the conversations we've had leading up to it. So this is designed for developers in the sense that we opted to use JavaScript as a language people will write code in for blocks. It's one of the more popular languages. We do have real-time logging and debugging tools. So using our data stream network, we can very easily let you guys know if there are any errors by just publishing on the channel as well. Deployment, we understand that for the most part, everyone has build processes, and we provide a command line tool as well as REST endpoints for you to deploy any new block. So a lot of people get excited that they can put their own code, serverless functions on the cloud and just execute it. But to help people get started, we have a blocks catalog where if you visit our website, you'll be able to see the kind of things we have seen people ask for. So in every possible use case, chat, geolocation, we've partnered with companies like, products like IBM Watson, Ring Central, and I missed a couple, sorry, Clarify. Yeah, so the whole idea is that these are pre-built blocks that you can just clone really easily and start working on them right away, deploy them within 2 minutes, and then basically have language translation ready. Just to give you an idea of one of the blocks plot outliers, we have an open source charting library, Project Eon. And it was great. You could point it to a data stream, and you'll see real-time chart appear on your browser. But then you have things like outliers and things like that, and those thresholds change. So with blocks, what you can do is as the messages are being sent through the network, you can basically specify the outliers, and they'll show up in your real-time charts. Game logic, we discussed this earlier, same thing. We have a block to help you get started with a simple hangman game, but I think it's more of an example of how you could use blocks to introduce some kind of game logic. Language translation, this is really cute, and it's something a lot of people have asked for. So when a message comes in English, you could quickly make a third-party API call within blocks. You could get the message translated into a couple of languages, published on separate channels. Now, as your clients are coming online, they can choose what channel they want to subscribe to. They could subscribe to the Spanish channel, and they'll be getting the same messages in Spanish. So this is just an overview of where we have come, and where we see ourselves going with the introduction of blocks. So currently today, just people using our data stream networks, we have about 300 million devices. As far as messages that go through our network every month, it's about 1.8 trillion messages that we serve up. We are globally replicated across 15 data centers, and the whole promise is within a quarter of a second, your message should be able to reach your intended target. That's all I have. Any questions?
Just for maybe one or two while we start to... We got time for maybe one or two while we start to transition between the speakers. No.
Awesome.
Covered all points. Okay, I just want to remind you quickly as we transition. Actually, first of all, I should say, is Yoche here? No? Yes? Yes. Excellent. Okay, so if you come down in front, we can start to get you set up on the laptop. Just a quick reminder that, oh, sorry. Please do show your appreciation. Thank you.